Welcome back to your Valves Industry Flash Learning Series. In this segment, we continue our journey through the essential phrases and concepts that shape the world of valve engineering, maintenance, and operations. Whether you are just starting in the industry or seeking to deepen your technical vocabulary, these cards will help you build a strong foundation for effective communication and decision-making in the valve sector. Let's dive into cards 26 to 50. Exploring each term in detail, with clear definitions and practical examples to anchor your understanding. We begin with the triple offset butterfly valve, an advanced design that incorporates 3 distinct offsets in its sealing geometry. This configuration ensures a tight zero-leakage seal, even under demanding conditions such as high temperatures and pressures. For example, in refinery applications where safety and performance are paramount, specifying a triple offset butterfly valve guarantees reliable operation and metal-to-metal seating integrity. Next, we encounter actuator stroke time, a crucial parameter in automated valve systems. The stroke time measures how long it takes for an actuator to move the valve from fully closed to fully open, or vice versa. Adjusting this timing is essential in applications like emergency shutoff systems, where rapid and precise valve movement can be critical for safety and process control. Valve signature analysis brings predictive maintenance into focus. By monitoring trends in valve behavior, such as resistance during opening or closing, engineers can anticipate maintenance needs before failures occur. This proactive approach helps minimize unplanned downtime and extends the life of critical assets. Handling abrasive and viscous media requires specialized equipment, such as the slurry isolation valve. Designed for tough environments like mineral processing pipelines, these valves ensure reliable isolation, preventing leaks and reducing wear from harsh slurries. Fire safety is a non-negotiable requirement in many industries. Fire-safe valve certification, such as compliance with API 607 standards, assures that a valve will continue to function even after exposure to fire. This certification is vital for protecting people, property, and the environment in hazardous locations. The blowout-proof stem design addresses a key safety concern: stem ejection under pressure failure. By mechanically securing the stem, this design adds an extra layer of protection, especially in high-pressure gas services where safety is paramount. Routine maintenance often includes seat ring replacement. By allowing for quick and easy changes of the removable seat surface, this feature reduces downtime and ensures continued valve performance. For example, a scheduled seat ring replacement can be completed in less than 30 minutes, keeping operations running smoothly. Before any valve is dispatched for service, it must pass a hydrostatic shell test. This pressure test checks for leakage through the valve body, verifying the integrity of the shell and ensuring the valve can withstand the demands of its intended application. Understanding the NC leakage class helps engineers select the right valve for the job. This classification system defines allowable seat leakage, with Class 6 representing the tightest shutoff. Testing to a specific ANSE leakage class ensures the valve meets the required performance criteria for its application. Double block and bleed systems are used to isolate and safely remove pressure from both sides of a valve. This configuration is especially useful during maintenance or line shutdowns, providing an added layer of safety and process control. Maintaining a reliable seal under varying pressures is made easier with a live loading packing system. By using springs to apply consistent gland load, live loading extends the life of packing materials and improves sealing reliability, even as process conditions fluctuate. Correct installation is critical, and flow direction marking provides a clear indicator of how a valve should be oriented. Checking this marking before mounting ensures the valve will function as intended, especially for directional devices like check valves. For applications involving toxic or hazardous chemicals, bellows seal valves are the standard. The metal bellows design prevents stem leakage, protecting personnel and the environment from harmful exposure. Position feedback transmitters are key components in modern control systems. By sending real-time data about the valve's position to a central controller, these devices enable precise monitoring and adjustment. Detecting a lag in valve opening, for example, allows for timely intervention before process issues arise. Regular testing, such as the ESD valve response check, ensures that emergency shutdown valves will perform when needed. Completing these checks on a quarterly basis helps maintain safety and compliance with regulatory requirements. Plug valve operation is straightforward and reliable, making these rotary valves ideal for simple on-off service. Their cylindrical or tapered plug design allows for quick and positive flow control. In flammable service environments, preventing static charge buildup is essential. Anti-static devices integrated into valves, such as those used for LPG duty, safeguard against ignition risks by ensuring any static electricity is safely dissipated. Valve trim erosion is a common issue in high-pressure throttling service. The internal components of a valve, known as the trim, can wear over time due to the force of flowing media. Regular inspection and material selection help mitigate this problem and extend valve life. To protect valve seats and maintain integrity, stem travel limitation restricts the movement of the valve stem, preventing over-travel that could damage internal components. For critical applications requiring redundancy or ease of maintenance, a tandem valve configuration installs two valves in series. This setup allows one valve to be serviced while the other maintains isolation, enhancing both safety and uptime. Lockout-tagout (LOTO) procedures are fundamental to safe maintenance practices. Valves equipped with LOTO mechanisms prevent unintended operation, ensuring that energy sources remain isolated during work on the system. Solenoid valve control leverages electromagnetic force to actuate valves rapidly and reliably. This technology is widely used in automation systems, enabling quick switching and precise process control. Monitoring the valve open percentage provides valuable feedback on flow regulation. By knowing exactly how far a valve is open, operators can adjust process conditions for optimal performance. Angle pattern globe valves, with their 90-degree flow path, offer a compact solution for installations where space is limited, such as vertical condensate lines. Finally, over-torque prevention devices protect valves from excessive force during operation. By stopping the actuator before damage occurs, these devices safeguard both the valve stem and the overall system. With these concepts in hand, you are now better equipped to navigate the technical language and operational demands of the valves industry. Each term represents a building block in your growing expertise, supporting safe, efficient, and reliable operations in every aspect of valve engineering and maintenance.